Okay. So we're going to be having a look at the perimeter of a sector. Okay, now, some people might say, well, why are you calling it perimeter of a sector? The perimeter of a circle is the circumference. However, when we're doing a sector, we're not doing all of the outside of it, but we are going to need to know what the circumference is. So let's write down what that is first. We know that the formula for circumference is equal to pi times by d. You could also put 2 pi r, we know that. So the perimeter of a sector is either pi times by d or 2 pi r. So let's have a go at this one here. We'll do example 1, like so. So the first thing I'm going to do, always, I'm going to write down what the radius and the diameter is. Now in this one here, my diameter is actually 6, which is all the way across, so 6 millimeters, like so. And my radius in this case is equal to 3 millimeters. Now, before I can find out the perimeter of this, the part that I need, which is going to be the tricky part, is this curved edge here. Now you might think to yourself, all I need to do is find the circumference and divide by 2. Now I'm going to show you why you can't do that. If I take a circle like so, there's my circle, and I know that this here is the circumference, like so. So my circumference is equal to pi times by d. Now when I divide by 2, what I'm doing here is I'm basically cutting this in half. That didn't do what I wanted it to. When you're cutting this in half, so when I'm cutting it in half, this is what I've got. But what is missing here? What is missing? When you divide by 2, yes, you're finding half of the circumference, but the problem with this is the thing that's missing in this is the bottom. Okay? The thing that's missing here is this diameter. When you divide by 2, you're only finding the curved edge. Okay? So let's have a go at this one then. So the first thing I'm going to do is work out all my circumferences. My full circumference, which is equal to C, is equal to pi times by d. And pi times by d, d in this case is 6. So it's going to be 6 times pi, which is equal to, I'm going to leave in terms of pi for now just to keep it more accurate, equal to 6 pi. Now when you divide by 2, you're not finding the full circumference. What you're doing is you're finding the curved edge. So the curved edge, or the top of this, I probably should have done that in red actually. You can see that that it's this part here. So the curved edge is equal to the full circumference divided by 2. So 6 pi divided by 2, which is equal to 3 pi. Remember that this is the distance, so the units on this are centimeters. So I now know that this curved edge is 3 pi. So to find the full perimeter of this, I'm going to need to add the diameter, so this part here. So my perimeter is equal to 3 pi, which is that curved edge, plus the diameter, which is 6. Now, if you were doing this on a non-calculator paper, this is how you would leave it. 3 pi plus 6. However, it's asking us to do it to one decimal place, so it's going to be 3 pi plus 6 which gives us the answer here as 15.424. So I'm going to round that to one decimal place as 15.4 millimeters. Okay, have a little go at that one on the right hand side there. In fact, I'll keep that there so you can see it. So have a little go at that one on the right hand side. Now, remember, we did very similar to this when we were doing the sector. To find the curved edge of this one, it's not going to be half this time. It's going to be 3/4 for that curved edge. So you find out what the circumference is. You could even do it straight away. So the curved edge is equal to 3/4 times by pi d. I'll give you a starting point. But then don't forget, this here is your radius. So you're going to need to write down what the answer is. I'll let you have a go at that, and then when you've got the answer, pop it in the notes, pop it in the chat. I'll give you a second to have a go. So when you've got the answer, pop it in the chat. So I'm going to start going through this one. So in this one here, I know that my radius is equal to 3 millimeters. I know that my diameter in this case is going to be equal to 6 millimeters. This is 3/4 of a circle. So to find that curved edge, it's going to be 3/4 of the circumference. And 3/4 of the circumference is going to be equal to 3/4 times by pi times by my diameter, which is 6. So let's do that. So fraction button first, 3/4 times by shift pi times by 6. Leave it as leave it in pi for now. So this here is equal to 9/2 pi centimeters. Now the thing that's tricky with this one is to spot that actually you've got two extra parts. I'm going to zoom in really close there. You've got two extra parts on this. And your two extra parts are this part here and this part here, which is going to be the 3 on this one and the 3 on this one. Okay, so when you're adding these here, so the full perimeter is equal to the curved edge, which is 9/2 pi, plus 3 plus 3. So it's very similar to the one, because here you've got plus 3 and plus 3, because it's the double of 6. So plus 3 is equal to 9/2 pi plus 6. I'm going to do this into one decimal place, which in this case is equal to 20.1 millimeter. Brilliant. Super. So let's have a go now at our next one. Now this is where we're going to get a little bit trickier. Not that much trickier because it's very similar to the arc length. Sorry, very similar to the sector. We do need a new formula which we're going to write down. Now, if I've got a full circle here, let's draw a full circle. That's not a very good circle. If I've got a full circle like so, and I've got here a particular portion of it, theta, this here is called the arc length. This is called the arc length. And in a very similar way to the way that we find out our the area of a sector, to find out the length of the arc length, your arc length is equal to theta over 360 times by the full circumference, because I'm finding the length of this, which is going to be times by 2 pi r, which is our circumference. So this here is the formula for arc length. Theta over 360 times by 2 pi r. So, hopefully you've got that down. Let's have a go at this one here then. So there's 3 parts that we need to find out here. We need to find the length of this arc, and then we need to add the radius here and the radius here. So, same as always, the first thing I'm going to do is I'm going to write down what the radius and the diameter is. Radius is equal to 10 meters. Diameter is equal to 20 meters. And to find my arc length, this is equal to theta over 360 times by 2. Hey, it's not 2. Times by 2 pi r. So this here is equal to, theta in this case is that angle, isn't it? So it's 123 over 360 times by 2 pi times by my radius, which in this case is 10. So let's put that into my calculator. Remember to press the fraction button first. Fraction button, 123 over 360 times by 2, shift, pi, open bracket, times by r, which is 10. You can leave it as a fraction if you want. I'm going to write it to 1 decimal place. So my arc length here is equal to 21.5 centimeters. 21.5 centimeters. Which is equal to 10 plus 10 plus 21.5. (10 plus 10 plus 21.5), which is equal to 41.5.